Hello friends, I'm back in another video and today I'll be discussing about Enterprise Scenario Copilot. So this is my enhancement of the previous project which I was talking about. So let's go to it. So previously we were talking about like running the Scenario Copilot via the Google Colab notebook. However, this time I'm going to make a FastAPI server and I'm going to connect it with the backend, that is the PostgreSQL. Also, I'll be using some SSE server-side events that is going to simulate a real-time environment which is going to be useful for the modern front-end UIs. So you can see that this is much more advantageous, as in the data has been saved inside inside one SQL database, and so the data is not being lost once the program is shut down. So this is the 4-tier architecture. In the bottom layer, we're going to use a Postgres connections pools, and above that is going to be protocol layer. This is going to run an isolated MCP, fast MCP subprocess, which is going to check for a spatial constraints. Like previously, if you imagine, we had this validation tool, so that only I'm going to use in this protocol tool layer. Also, I'm going to make a line graph coordinates. That is I'm going to use the state flow loops and the human in the loop gates that I was showing previously also. After that, I'm going to move on to the API transport layer. So this will expose the asynchronous REST and server-sent events. So as discussed previously, what telling about this pedantic schema. So this whatever the data that you're going to get from the Gemini LLM is going to make sure that the Gemini LLM um, is going to follow that same format. This is the use of the scenario schema. And in the workspace, you can say that in here we're going to use a type dict. So this will help us to manage the graph memory, historical inputs, and error logs. And this is going to use it via the scenario state. And you can see like in the description given here. Next, after that, we're going to create an external MCP validation server. So why you're doing this is because like sometimes when you're running multiple applications and that application has to connect to a same, for example, an MCP tool. So here we're taking the validation of a particular condition. So imagine you have some two to three different ML or any other models that wants to access this MCP tool. So for that it's going to be useful. Otherwise, in the previous in the notebook, only one program can access this at a time. So next we're going to go for the state persistence. In this we're going to use a DB and we're going to save this whatever data we're going to generate. We're going to save it inside PostgreSQL via the memory saver for asynchronous database checkpointing. And later, when you want to query the database, you can query it and we can see what all kinds of data was there. And even we can make it like convert it into CSV, or we can convert it into a MySQL type. So you can even see it in the MySQL workbench as well. Next, like in the previously I was discussing about the state graph orchestration. So here also we're going to create a quick generator. So in this generator we're going to have the LLM that is going to handle the prompt and the scenarios. And then this thing we're going to feed into a validator. And this validator is going to check whether whatever the generator has created, it is within a particular limit or not. And after that, you're going to send it to the MCP server. Otherwise, if something is wrong and the number of retries are finished, then we can give it to the human reviewer. And by the time the human reviewer will, by the time human reviewer is going to decide, the process is going to be stalled in the background. So next here, the streaming API layer. So this is going to expose the asynchronous endpoints, and it's going to get a real-time execution delivery. So you can see the code which I put here. So this is going to create a server send events as well. So this is the execution lifecycle. First, the client is going to post a request to the generator, that is the Gemini LLM, and from there it is going to call the validator. The validator will check whether the output which the generator has given is it correct or not. Otherwise, it's going to give a feedback loop with the errors by the generator. And whenever that it is ready, so we're going to give it back to the we're going to give it back to the user in a front end manner via the live SSC stream. Like this is going to highlight how the freeze and resume will work. So in the first phase, we're going to the LangGraph will encounter human review code node. Okay, and the status serialized to PostgreSQL keyed by thread ID. So we're going to create a specific thread ID where when you're going to give a prompt, and with respect to that only, the we're going to save that check as a checkpoint in the Postgres saver as well. And whenever we get any approval to continue, that time we can take this data back from the Postgres saver, and we're going to carry on with the process. So I can say that I engineered a agentic microservice in FastAPI and LangGraph that orchestrates from tool validation using MCP protocol. And this also handles the human-in-the-loop process and server sent events. Okay, so for the PPT, let's go and look at the code. So here, this is the main project file which I'm going to do. So as you know that I'm going to use the Docker for whatever process for the PostgreSQL part, and nextly I'm going to use some various validator database files and other things as well. So let's start with the main.py. Okay, so this is the main. um, from here we're going to start every process. So this is what I have done previously, that remains the same. So discussing about the approval status and the generator scenario, I have put this extra. So this is going to tell about like when you're going to connect to the database, and when if you're going to how you're going to store that checkpoints. So this is all about it, and we're going to load it from that .env file, the Gemini LLM API key, and after that this is for the approval. So whatever the thread ID is there and whether that has been approved by the user or not is going to display here. And with the help of FastAPI, we're going to do a post command on this URL, you can say. And this is all the data which is going to go in the prompt. What's the validation errors, iteration count, and whether that that has been approved or not. So this is going to go as a server sent events. After that, we're going to go for that event generator. So this will yield the data where the this will yield the data as a SSC data blocks, and it's going to give a streaming response with the event generator and the media type to be as this. After this, we're going to come to the approve phase. So in approve phase, what we're going to do is that till we're going to first of all check whether a thread has been saved in the Postgres checkpointer or not. And if it's not, we're going to tell that there is no thread that has been there, and we need to generate a first thread ID. And then after that, if we have found that thread is there, then we're going to resume the graph execution. So in this, we're going to pass whether the user has approved the input or is not approved the input, and based upon that, we're going to return the whatever is the status back. So as you see, the status will go back in the loop, you can say. Here we'll go back. So whatever the status is there is going to go back where that at this place. Okay, yeah, this here. So we'll go back to the janitor. Okay, so this is the database file. So as I told you that I'm going to use the asynchronous Postgres SQL. So in that I'm going to use this specific property.aio that will help for me to connect to it asynchronously via a lang graph. So this is the this is the URL which I'm going to put, and this is the data. So this is going to create a agent DB inside a Docker container, and after this we're going to this is the basic thing like data manager. What's the pool? So it will define a connection pool that will help us create a checkpointer tables if the value has been missing. So for that, you're going to create a DB URI. There's a database universal resource index, and after that, you're going to put other kind of values. You're going to put like auto commit is true. So auto commit is true is very important if you're running the the program for the first time. Otherwise, it will fail. It'll give you an error. So previously, I was put as false. I put this auto commit as false, but right now I put it as true because in the starting I was getting an error. And whatever the values it has been giving, so we're going to put this in this check pointer, and then we're going to run a setup command on this, and you're going to return this check pointer back. So this check pointer is going to help us to get the particular thread ID status from the PostgreSQL. If the from the PostgreSQL, if the human has approved the process, and after that we're going to create a database manager instance, and we're going to call it from here. Okay. And here we're going to check whether any exception is there, and if the exception is there, we're going to pin the trace the trace back in the main file, sorry, in the terminal. So, so this is how we're going to build the agents. So here we're going to define what the pedantic schema that I was discussing about. So pedantic schema is the smallest amount of data, like every entity must follow this. Like we're going to have like various entities, right? The vehicle, and we're going to have a person, so this must follow this from this schema I can say. And after that we go to get another schema scenario, like this is how we want Gemini LLM to give us the output. You can see here I used it here. And then we're going to create a scenario state. So the scenario state is, as I told you, is kind of a workplace that will help to pass the data around to various nodes. So this is the LLM setup and the nodes. It's a generator node and other things. So in the generator node, basically I'm going to attach, um, tell the LLM like give the system prompt and others like the chat prompt template. And after that I'm going to you know change this prompt template as structure template. You can take either of these, and based upon that the you invoke the LLM. After that you're going to return the value, whatever value you get in form of result.model dump. Okay. So after that we're going to have this validator node. So this is validator node. I've created this as a separate MCP tool, so we can ignore that for now. And here this is the human reviewer node that is going to create an interrupt, and whether the human wants to or go through that whatever it has tried. After that, he's going to create a root validation, In that, it will check whether that iteration has been less than a particular number or not. After that, you go to have this graph builder. So in this graph builder, we go to create a workflow, you can say. So starting, we're going to start with the start only. So whatever operation you're going to put in LangGraph, all starts from start and ends at end node. So in between that, whatever edges you want to add, that is a generator and the validator and other things and the human reviewer. So that you're going to do, and then we're going to compile and return the output with the checkpointer which we had for the previous things. Okay, so this is about the code, and let's go ahead and see some real time, like how I got the data till now. Okay, so I've gotten inside the agent DB, so where all those data have been stored, and then we can type /dt. All the databases or the relations is going to display here. So these are the previous checkpoints which I had created, and with the help of this you can see all the thread checkpoints that has been saved. So these are the all previous checkpoints that I have created previously. So all the checkpoint data has been come here. So you can see the data has been stored. All data has been stored inside the database comfortably. For this, I still have the Docker running. So let's go there. Yeah, so this is I'll run this now. So I need to go to the URL.